Okay, we're staying with rational functions, one-sided. And here's the tip. When it's rational and it's one-sided, what we're looking for is end behavior. You're headed towards an asymptote. And what is the graph doing? Is the graph headed towards positive infinity? Is the graph headed towards negative infinity? So for these rational, one-sided, the graph is headed towards an asymptote. And what is the end behavior as it heads towards that asymptote? So one way to do it, I showed you the substitution method. You could plug in, so this just says you're going to come from positive 1 from the left side. So from the left side would be 0.9999, and you can plug that in, and you would get a positive 0.999. A positive number, subtract a larger number. So let me cover that. Oops. So if you substitute 0.999 into here, you'd get a positive 1 over a negative. Positive divided negative is negative. Since we know we're headed towards an asymptote, we know right away we are headed towards negative infinity. But you also can use the parent graphs and just graph that. I think that's what I did here. This is just a rational function shifted over to positive 1. So we've shifted. This is 1 right here. That would be the graph. I probably needed to make it a little bit more curvy like that. And we're getting close to 1 from the left side. So we're coming from the left, getting really close. And look at, we're headed towards negative infinity. So that is, let's see, what would be the next one be? Now, coming from the right, so coming from the right side of 1, we would have 1.0001. Well, a number bigger than 1 subtract 1 is a positive. The numerator is a positive, so positive infinity, and you can look graphically. All we did was take the normal parent graph, we shifted it over 1 to the right, and then we can see what the end behavior is doing graphically. And I think that might be it. Yep, that's it for rational functions, one-sided, kind of quick ways to tell what the answer should be.